our underwriting processes, etc. So in this session today, Rahul and Jean will illustrate how AI agents, like those that power their KorrAI Trail platform, can surface specific risks that routinely drive underwriting friction, uncertainty, and exclusions. Their focus is pragmatic. It's about using AI to augment engineering and underwriting judgment, not replace it. It's about boosting throughput, repeatability, while keeping that final decision making, very firmly in human hands. So if you've got any questions as we go through the presentation, please put them in the chat and I'll monitor them and introduce them where appropriate. So let's move on to introduce our speakers. Rahul Anand is a computer scientist and a serial entrepreneur, and he's the co-founder and CEO of KorrAI. Over the last few years, he has applied AI and geospatial technology to help infrastructure owners and insurers better understand and manage risk through greater transparency. And Jean Poirier is an engineer with a background in mining and socio-economic consulting. He has supported public and private sector clients by evaluating project-based risks to inform investment and development decisions. He now works in technology as the product manager for Trail at KorrAI, where he's building tools that expand risk engineers' ability to deliver high-quality desktop risk assessments. So with that, Rahul and Jean, thank you for your time today. The floor is yours.
Thank you, Patrick. So before we start, a quick snapshot on who's in the room and who registered, and obviously thank you to EMEA. So as of last night, we had over 300 registers representing 85 companies across 50 countries. And that level of global participation tells us something important. The challenge around scaling desktop risk studies, DRAs, and engineering judgment isn't local or isolated. It's being felt across markets, portfolios, and regions. And thank you to EMEA for hosting, and thank you all for taking the time to join us today. So I think Patrick did give a brief background about ourselves, but my background is in computer science and engineering, and I've spent the last several years building systems for risk assessment. And joining me today is Jean Poirier. And behind us is a team of about 20 geospatial scientists, AI specialists, and software engineers. And together as KorrAI, that's the group that's been building the agent-based approach to DRAs that we'll walk through today. So on the insurance side, in terms of who we are and what we do, we support teams assessing large infrastructure heavy risks, where site conditions and DSU exposures really matter. We also work directly with large infrastructure owners, including mining companies, data center operators, who need to understand ground and risk and site risk early on and also continuously, not just at a single point in time. And we work closely with civil and geotechnical engineering firms who are often producing or reviewing the same technical material that insurers rely on. Across all three, the common thread is same. There are complex sites, decisions are evidence heavy, and there isn't always the time or capacity to get the depth everyone would like. And our role in this ecosystem is focused on remote site due diligence and monitoring, bringing together submission data, external context, site intelligence, so teams can apply judgment with better visibility. Just to set the expectations for the next hour, here's how we'll structure today's webinar. We'll start by grounding this in construction insurance and why scaling engineering judgment has become harder, not easier. Then we'll walk through how desktop risk assessments are typically done today, where the bottlenecks show up, and why those challenges compound under pressure. From there, we'll talk about what it actually means to scale judgment, not by replacing engineers, but by changing how work gets done around them. We'll spend some time on AI agents and where do they sit in the wider AI umbrella, in the context of DRAs, including a walkthrough, and then close with what changes, what doesn't. and what this means in practice. If nothing else, the goal is to give you a clear mental model you can take back to your own teams. With that, I would like to get a quick pulse from the room. And this is a short survey on DRAs and how AI actually is being used today. You can actually scan the QR code on the screen. And I think John is also going to give a link on the chat with which you can open it on your desktops and then see it. And obviously, we'll come back with the results during the later course of the webinar. So I'll give a couple of seconds for you to scan and open this link. The first question, in this survey is very interesting. It's deliberately simple. So the question is, what's the one word that comes to your mind when you think about DRAs or desktop risk assessments in the context of, obviously context of construction insurance? It's a very small question, but whenever we do this in a room full of underwriters and risk engineers, the results are very interesting. It tells us a lot about how this works, how it feels in practice, not how it is described in process documents.
So maybe while we wait for some of those responses, if anyone wants to chime in and maybe indicate what word that they use to describe desktop risk assessments and kind of explain the rationale behind that, that would be greatly appreciated. So yeah, just go ahead and chime in.
The question is, what's the one word that comes to your mind when you think about DRAs, desktop risk assessments? So while you are responding, let's keep going. And let's zoom out for a second. So construction insurance is different. And that context explains why judgment really matters so much and why scaling it is hard. So let me start there. So one of the defining characteristics of construction insurance is that a single misjudgment doesn't play out immediately. It can have consequences that last for years. These policies are multi-line. You're not just covering the physical damage, but the business interruption and the project-specific risks that interact with each other. There's also multi-year. Once a policy is bound, insurers are effectively logged in for 24 to 36 months, often longer, when you include maintenance periods. And there are multiple insured involved. There are multiple parties, multiple stakeholders, from owners, contractors, suppliers, and designers, and all with different incentives, responsibilities, and failure modes. Obviously, the objective is same, but the failure modes for each one of these parties are different in different point in time. The result is that early decisions carry a long tail. If something is misunderstood at the underwriting stage, the impact doesn't show up as a clean correction. It shows up later as disputes, delays, claims, and second-order effects that are hard to unwind. So if construction insurance has long tails, multiple stakeholders, and a very little room for error, the obvious question becomes, how do you scale good engineering judgment under those conditions? Especially today when volumes are up, the timelines are compressed, and experienced engineers are stretched thin. And that's what the next section is about, what we're going to talk about. So when we talk about judgment, we're not talking about a set of rule or a checklist that one needs to fill. Judgment in engineering is something you earn over time. It's built by solving real problems, dealing with edge cases, asking the right questions, and then seeing what actually happens after decisions are made. Over the years, that experience turns into pattern recognition. You start to recognize when something looks familiar, when a design is practical, or when the risk doesn't quite sit right, even if the data looks fine on paper. And that judgment is highly context dependent. Two risk engineers can look at the same submission, the same set of drawings, the same data, and reach different conclusions depending on the site, the construction phase, to display. Is my screen visible, John?
Yes, you're on the engineering judgment side.
Yeah. So two engineers can look at same submission and same drawings and same data and reach different conclusions depending on site, the construction phase, or the broader project constraints. That's also why judgment can't be fully automated. In geotechnical and construction risk, there's always uncertainty. There are things you simply don't know yet and things that only become clear later. So the challenge isn't replacing judgment. The challenge is how to support it, preserve it, and apply it consistently as volume increases. When we talk about why scaling judgment matters today, it's because several pressures are hitting at the same time. First, the scale of infrastructure itself is changing. Data center construction alone is already $200+ billion market, and it is projected to nearly double by the end of the decade. These aren't small projects. They're large, complex sites, often built fast in the recent times, and often in challenging ground conditions. And they require real judgment to assess properly. At the same time, the timelines are compressing. With the rush to build data centers, build cycles are getting shorter. What was previously 5 to 6 years now is compressed into 3-year cycles. Underwriting windows are tighter, and there is less time to digest complex submissions before decisions needs to be made. Now that pressure feeds directly into DSU exposure. When projects are tightly sequenced and highly capitalized, small misunderstandings early on can turn into significant delay and claims later. And finally, all of this is happening while the workforce itself is shrinking. This is not something which we are witnessing in underwriting or probably risk engineering, but many other workforces. Now, in the context of risk engineering, nearly 40% of experienced risk engineers are expected to retire by the end of the decade, and the pipeline behind them isn't keeping pace to the demand. So when you put those pressure together, something else becomes clear. Demand is increasing along one curve. Experienced engineering capacity is moving along another. And the distance between them isn't something you can close by hiring faster. Judgment compounds slowly. It's built over years, not quarters. So what emerges isn't a short-term capacity issue. It's a gap. And everything that follows is shaped up by that constraint.
Thanks, Rahul. With that said, I'm going to start kind of getting into the workflow, but really quick, I see a question in the chat there. So what's the basis for the 40% of risk engineers retiring? We do have the source for that, which while I speak, maybe Rahul can provide that source in the chat.
Absolutely.
But really quick, I just want to go over the workflow here. And most of you already know, but what I want to do is kind of set the stage before we talk about where friction starts to pile up and then get into kind of how AI fits with each of those phases. So next slide, please. So this is a very simplified view of the more cyclical process that most of you are familiar with. So it starts with receiving a submission. There's some document gathering activities back and forth with the broker to understand the project and kind of get your footing. But the submission package itself is only one piece. As you know, there's no shortage of tools and data sources external to go obtain. And there's a variety of things with respect to NatCat, looking at claims history, things like that. And these are all reviewed. And I was just looking at some of the survey responses, which thank you everyone for doing that. And it does look like the reviewing of the submission documents and gathering that external data, those are the two largest time sinks for this process. But then what happens is you start to cross-reference and trying to reconcile all, well, in some cases, conflicting information. You're looking at national data repositories versus local repositories, especially for things like karst regions and things like that. And in some cases, there might be errors in the submission documents, or the project schedule is evolving and changing, and you're having to review those multiple times throughout the risk assessment process. And obviously, that's very tedious. It's time-consuming work that pulls engineers away from what they really should be doing. And it also leads to gaps, especially when we're talking about rework that's required. Given the compressed timelines that Raul mentioned, things inevitably slip. So we end up going back to brokers, back to clients, and sometimes this happens multiple rounds to inevitably get the information that's required. And really what I want to highlight here is all of this time-consuming work takes away from the most critical phase, which is where the engineering judgment is actually applied. It's where the information is synthesized, you combine it with experience, and then you make the call on the level of risk and the overall tolerance for that submission. So that's kind of where the focus is today, is really how does AI get applied for phases 1 through 5 so that more time can be spent making better decisions in phase or section 6 there. So touching more on some of the existing challenges, both in terms of the process as well as how those challenges kind of create complications when you looking to apply AI to them. So like I mentioned, everything seems pretty linear and straightforward on paper. That's not really reality. There's a lot of kind of small nuances and challenges that come into play. And the first one, which we've already kind of touched on, and again, the survey responses reflect this, and I'd be really interested in comparing them directly. And by the way, we'll share the survey results. Raul will share them during the call, but we can also provide them to all attendees afterwards. But a lot of the time, again, going back to those first 5 phases, is being spent on more low value work. So trying to fetch all the relevant information, the evidence that's required to make these judgment calls on the different risks that are being assessed. And then also estimating, potential loss scenarios and things like that can actually inform the policy itself. So that's obviously a challenge in terms of scaling judgment. Really where the focus needs to be is on that data gathering piece and the triaging of that data, and that process needs to be able to occur cyclically. And in a similar vein, we also have more data than ever. And a lot of this data can be super valuable. And our experience working with project owners, they're utilizing much of this. So there's a heavy reliance and a growing reliance on LiDAR data to assess site conditions, vegetation, things like that. And the difference is that the insurance workflow doesn't have the time to adequately process all of that information. We have a growing reliance on IoT sensors and things like that as well. And then there's also some more mature technologies that are more grounded in the existing insurance workflows, like NatCat models and things like that. And but it all boils down to risk engineers, underwriters altogether still don't really have the time to properly apply all of this new data to elevate the level of transparency for the site-specific risks. And then finally, even when the data exists and you even have time to sit down and properly review all that information, you're also forced to switch context. Going back to the owner mentality, owners have teams doing this work, right? And they're also focused on one site, where on the insurance side of things, you're juggling multiple submissions often at the same time. You're having to go back and forth between documents, cross-check things, update information, while still being constrained by the information that's being provided by inevitably the owner, which again is just a glimpse, right? So this creates a lot of challenges, and it's difficult to discern what signals an engineer should use to inform their decisions. And if we look at different projects that could be right down the road from each other, they could have a completely different risk profile, right? So you have geological conditions like the karst map here that can change the risk profile. You have the nature of the project, the foundation, the structure itself, how that structure is going to be used, what the DSU exposure is. All of these things really make it so that the risks can't be templated. And when we're looking at, Raul will touch on this more, but the traditional processes in terms of how to apply technology to this were more of a templated process. And that just didn't really work. So all in all, the context for these sites in assessing site conditions is very diverse. You have the geological hazards, like I mentioned, you have climate, weather scenarios that differ. You have construction timelines that vary depending on processes being used. And even like the regulatory environment can be very different. So traditional tools treat each of those in terms of assessing risk independently. But that doesn't actually scale in terms of an end-to-end solution, because the engineer is still required to bring and map all of that context together and string together the rationale for that risk story. And that brings us to the importance of traceability, and it's a big focus on the work we do at Core, and that's making sure that whatever decision is being made or assisted is traced back to why. And so if we look at an example here, we have engineer one that is looking at risks of a site for public fire safety. And they might rank that as good because there's nearby fire stations and there's water availability on site. Engineer two, though, looks at the same site, but they're emphasizing a different signal. So they're looking at issues with transport connectivity to that asset location because they know that there's a construction project nearby that overlaps with the construction schedule of the that same site. And so the access road from the fire station to the project is actually going to be blocked for part of that construction. So they actually rank that risk as a little bit higher. And both of these assessments are valid. It's just judgment that's being applied differently. And it's because the signals that they're drawing from the same context differ slightly. And it's not to say that either of them are wrong. The important thing when we're looking from an insurance perspective and getting into claims is making sure that the rationale for that decision is very transparent. So as engineers, we're well aware that one of the core reasons to maintain notes, and I'm sure other engineers here had their professors kind of drill it into their mind in terms of show your work, you get Parkland credit for it. But that very much holds true in terms of the insurance space. So when we're looking at claims and dispute resolution, that same work is really important. So when we're looking at AI systems, which Raul will get into, we need to make sure that we can maintain that show your work kind of mentality.
So thanks, John. So engineering judgment isn't the bottleneck. The time which is spent around judgment is. Too much effort goes into finding information, rebuilding context, and redoing work that already exists. So the question isn't how to automate these decisions. It's how to clear the path so experienced engineers can spend more time on the decisions that actually matter. So the question, so where does AI actually belong in all this, in this context? So most of you, I think each one of you who is attending today are already using AI in some shape and form. And AI is not new to insurance, especially if you look at hazard modeling. Those teams have relied on machine learning for years to generate catastrophic curves, loss distributions, portfolio level exposure views. Now that capability is already deeply embedded in underwriting and your decisions. If we go to personal lines or health lines, predictive models estimate claim propensity, lapse risk, fraud likelihood, even customer lifetime value. And those systems operate at scale and often processing millions of policies. And they have been doing this perfectly for the last couple of, I would say, last decade. And on the operational side, you have NLP system extraction systems that can extract data from broker submissions and long policy documents. Also, you would have seen, lots of IoT-based solutions wherein they put cameras on construction site and then they're able to monitor the quality of the constructions and so on and so forth. And to some extent, even use of large language models for assisting in drafting reports and communications. And all of these things work, and that is why they are being piloted or they are being commercialized. They work. And each of these tools serve a specific purpose, a specific solution to a well-defined problem. But in the context of engineering, in the context of what we do, in the context of when we are looking at a site, looking at a construction submission, what's missing in these tools is continuity. The ability to carry context across documents, models, assumptions, and decisions, from submission intake to the final assessment, without losing the reasoning along the way. And continuity also in practice comes down to three things. First is augmentation, bringing all relevant data sources together and not just extracting fragments from each one. Second is explicit reasoning, where decisions aren't just outputs, but the assumptions are steps behind them. The assumptions and the steps behind them are explicitly visible. And the third one is traceability, where every conclusion is linked back to evidence that supports it. And without those three, AI remains a collection of point solutions which can do things in isolation. And with them, it becomes something engineers or you can actually trust. The solution isn't a point solution. The solution isn't in another point solution to a problem here. So it is something that can carry context, decisions, evidence all through the same way. And that is where the concept of AI agents come in. AI agents, think of them like your co-workers who can do the same thing, carry context, decisions, and evidence all in one window. So let me go deeper into what an AI agent is. Where do they sit in the wider AI umbrella, and actually try to walk you through in the context of a DRA, desktop risk assessment. So first, the agent, when put in action, plans a course of action. For a DRA, this means it doesn't try to do everything at once. It starts by defining the scope. What risks matter for the site? Flood, geological risk, ground stability. the exposure around it. It identifies the right next step based on the submission, just like an experienced engineer would do. Second, it follows standardized practices built into master instructions, similar to policy or guideline documents which you have, right? That once a submission comes in, each one of you would have a set of instructions. So it has those standardized set of practices baked in. It's not inventing a new framework. It's operating inside your DRA structure, your underwriting guidelines, your checklist, same section, same logic, and same discipline. Thirdly, it uses different tools and data sources available to it. So instead of the engineer manually moving between geotechnical reports, hazard models, public databases, in the US, there is a lot of databases available from USGS. A lot of counties have their own flood maps, similar in the UK. UK has fantastic geospatial infrastructure and these kind of maps, and so in other parts of the world, including Australia. So these exposure tools, maps, emails, the agent pulls from all of them directly, and more importantly, it keeps the context intact while doing it. And fourth, it reasons through contradictions. So the geotech reports suggest the low concern, but the regional geology data tells a different story. It doesn't ignore that tension. It surfaces it, it works through it, and it records why a particular conclusion was reached. So the key difference isn't that it is faster, and it is not supposed to be faster. Its primary responsibility is to get it right. So it's that nothing gets dropped along the way. The scope, the evidence, the assumptions, and the final judgment all stays connected from start to finish.
Yeah, and that's an excellent point, Raul, around being faster. So a lot of generalized tools focus on latency. So how fast can a response be given? But when we're looking at these kind of critical decision making and gathering all the right evidence for something like a DRA, the focus is really more on accuracy. So there's a bit of a mind shift from a technological perspective in terms of how to approach building your your agentic infrastructure. And that's going to get us into what we do. So again, we have Trail, which is an AI native workspace to help automate these desktop risk assessments. And we use AI within our agentic infrastructure in many different ways. And all of it kind of is required to come together to produce that desktop risk assessment. And we actually have what's called a multi-agent platform. And all that means is that we have several agents that are operating and being orchestrated by a master agent. So essentially told what to do. And the benefit of this is that each agent is really good at certain things. So for example, we have one that's really strong at parsing through long, technical reports. We have another one that can interpret site images, like your drawings, borehole logs, even scan PDFs, things like that. And we have another that's really good at looking at structured data. So that's often your P6 schedule, or if it's provided in a CSV or an Excel sheet to really provide confidence that the different phases of construction are being extracted accurately. And this multi-agent framework is also one core way that solutions like ours, as well as other solutions in other industries that focus on very specific problems, differ largely from more generalized, especially LLMs, like ChatGPT and things like that. And the other core piece of our agentic platform is how we feed and restrict data into the platform. So it's not an open platform inherently. So that means it's not something that has access to the internet. We use a concept we call playbooks. And what those are essentially are predefined tasks that the agent can complete that have set inputs and outputs. So we know, for example, what adjacent infrastructure we want to look for in terms of an input And we also know what data sets are reliable and point the agent in the direction of that data set. And then the output would be, those same adjacent infrastructure or nearby pieces of infrastructure that actually can lead to a difference in the risk exposure or overall rating. And what this allows us to do is just really be selective, and that prevents hallucinations, or helps reduce the amount of hallucinations, and also makes sure that the quality of the data we're gathering is very high. And then the final piece pertains to KorrAI's kind of evidence layers. So in the intro, Raul mentioned that as a company, we have years working with infrastructure owners, utilizing largely geospatial information, satellite imagery to conduct certain analysis, especially when we're looking at surface and subsurface risks. And so we've brought that into our new platform, Trail. And what that looks like is being able to extract or augment submissions with very specific data layers. And these layers include things like subsidence or ground motion risk, assessment of soil stratigraphy, sinkhole risks, nearby pipelines. Your NatCap models feed into the evidence layers. And we also look at, in the next slide, things like groundwater, which is becoming more popular to assess in terms of DSU exposure, especially with these data centers, at least in our experience working with some of the owners. And then also looking again at surrounding infrastructure, whether that's to assess vehicular impacts, risks, or adjacent exposures. We also can use satellite imagery. So we can look at Sentinel-2 imagery and to run change detection. So that's actually utilizing machine learning to see where there was previous areas of cut and fill, which is particularly important if for instance, the geotech report is perhaps a little bit dated. This can help flag certain other exposures that weren't previously documented. And then we can even look or extract information on other construction sites, especially when we're looking at the data centers. We can potentially flag where there could be excess energy draws or grid instability issues due to several projects ongoing at the same time in the same region. So this all comes together in an interface that's designed to be simple for engineers to produce an assessment and dive deeper into the data. And again, it really focuses on traceable outputs for every response.
So there is
Next slide. Oh. Yeah, go ahead, Raul.
So yeah, I think there is one more thing to add. All these data layers which John explained here, I'm sure you already have, in some shape and form, at some granularity, access of these. The point here is that with the help of agentic AI framework, the ability to get more and more updated such informations gets easier. So I'll give you an example. Okay. So let's say you have a very sophisticated flood map out there, flood map from your NatCat team, and you have been using that for all your projects, right? But this site is let's say this site is in a county in the US, okay? And this county, under the umbrella of a recognized institution, let's say USGS, Okay, or if it is in the case of UK, it is the UK geospatial infrastructure, right? And they have decided to create, for some reasons, their own flood risk map, which is much more recent. Now, using agentic AI workflows, which once are integrated with these kind of authenticated and authorized websites, can actually go and look out for these additional, these data sets which can complement. So it's not about, replacing or upgrading the guidelines altogether, but it's about having access of this piece of information handy when you are actually spending in, on average. I just looked at the results. On average, the risk engineer spends between around 10 hours of time. So in that 10 hours, so instead of going out and finding out whether something like this even exists and then deciding whether to use it or not, these data sets can be readily available. So I just wanted to emphasize on that point. Sean, back to you.
Yeah, thanks. So we just wanted to. Sometimes it's easy to kind of talk about this, and it's hard to visualize. So we just have a quick demo here to kind of show you what this looks like. Again, this is our interpretation, but here during this demo, you'll kind of see where different components of AI start to kind of feed into the process. So Raul, I think with that said, you can go ahead and click play on the next slide. It should work. Fingers crossed. So that was just a quick summary. It's hard to kind of condense things down into a quick demo. But the point there was that each of those sections has at least one agent working, and the workflow that agent is doing in terms of the different models being used, the different data sources it's extracting, and kind of the specialty in terms of what tools it can use are all different. And the other piece of information that is important and not really visible on the demo is making sure that there's an understanding of the hierarchy of information. For instance, some of these external data sources can provide a nice snapshot of certain risks, but as an example, they shouldn't be weighed above what's being assessed in a geotechnical report that's been signed off by a PN. Patrick, I see a question there.
Yeah, I'm just interested. You obviously start by putting in a lat long to locate the project. It's understandable. But you said earlier that geotechnical conditions can vary over quite short distances. Also, things like flood exposure can. I'm just wondering, is the tool actually looking at the footprint of the project, or is it looking at the lat long?
Yeah, so either. If there is, there's a boundary file, like a vector file, for that site, we can do the analysis on the entire site and look at those nuances. Oftentimes, we find that we just have a singular lat long, and so we add a buffer to our assessment. For instance, if 100 meters over, there's a potential, or there's an area that's more karst prone, or there's been a sinkhole observed within a certain radius, then that's flagged. So we're not looking at a single point. We kind of create that buffer radius where the site boundary has not been provided.
But what about if you take it to maybe an extreme? What if you had a linear risk over several, tens or maybe hundreds of kilometers?
Yeah, so that is something that's being worked on currently with the product. So we're actually looking at some road projects, working. So we're a Canadian company. We have some projects going on where we're currently doing that work. So there's no real difference. It's just there's more processing in terms of the amount of data that needs to be processed to capture that.
Sure.
And in fact, the linear risk is a very, it's a very interesting use case. So we have worked with the Department of Transportation in the US, especially those sections where are prone to landslides, and put the tool on use. But it's a very interesting use case, Russ, there, because the amount of data processing section by section required there is huge. And having ability to be able to have the geospatial and the document intelligence baked in together is extremely important.
Yeah. Okay. That's helpful. Thanks. It's been a couple of questions that really tackle the same point, and that's is the tool comparing against industry standards or regional differences, for example, fire protection against NFPA?
Yeah, standards are a tricky one. As a technology provider, there's a legal gray area in terms of the distribution of some of these standards. Some of them are public, some of them are more privatized. So a user, if they upload as an organization, upload the standards, then that can be used in the assessment. But we don't default to providing access to those standards because again, it can be seen as that we're distributing those. So yes, if it's been provided, we have kind of a feature to be able to upload, standards or compliance documents, or even if you have standard operating procedures, they can be uploaded as well, and the assessment takes that into account.
And that would address regional differences in standards.
Yeah, so site specific, they could be linked to those. Yeah.
Okay. Got some questions coming through thick and fast now, if you don't mind us taking them. When you're looking at NatCat, are you considering seasonal differences?
Yeah, so NatCat is kind of a unique case. So we have a default service that we use, but we also understand that most insurers at this time utilize specific models, and oftentimes they have their own climate modeling team. So we just integrate with those in those cases, whether it's CatNat. I forget the name of Swiss Re's, I think, has one that's specific.
Nathan.
So yeah. Nathan is the one, yeah. So we typically just integrate for the existing solution. So
yeah. Okay. There's a couple of questions here that sort of come to the same point. Is the tool checking for errors as it goes through? So the example given is if you've put in a lat long, but the project information is talking about a different location, would it pick up that there's been a data entry error there or inconsistencies in the data? And then rolling on from that is the fundamental question: is has it been checked against a human analysis to validate and calibrate?
Yeah, exactly. So yes, we look at conflicting information. We had a case the other day actually where there was an error in the submission document around the county, and we were able to flag that. Omissions is a tricky one, but something we're continuing to progress on and have made some really cool headway there. And then the apologies, what was the second part of the question there?
Validation, calibration against a human review.
Yeah, so we have a whole validation protocol, and Raul's, as we summarize this presentation, is going to get into it in more detail in terms of what to look for and how to validate it. But when we work with a provider, what we typically do is look at some of their historic risk assessments and submissions. And we do a comparative analysis because it's not about just providing accurate information, it's about providing relevant information. You don't want the desktop risk assessment to be 100 pages. That's not super valuable. So we try to work with our partners to kind of match the evidence, again, what their engineers are surfacing and highlighting, and try to match that. So there's a bit of an onboarding procedure there, but it leads to a very comparable risk assessment, at least in terms of a first draft.
Okay, thank you. There's quite a lot of questions here. I'm going to let you guys carry on. But I'm just going to ask one more, which has been asked, and a couple of people have thumbs up. So it's obviously got a few people who want to know the answer. The question is around the carbon footprint of actually physically producing the report.
We have not conducted an analysis there, although we probably should. We use fairly quick models and then run them several times in many cases. So it's a lower footprint than some of the larger models. And the thing is we don't need to use some of these really large models because we're being very hyper specific. Again, going back to the playbook architecture that we have in terms of knowing exactly what inputs we need and then what outputs that'll create. So because of that, we're able to rely on faster, smaller models. And we also have our own servers in-house, so we're not as reliant on certain cloud providers for some of our analysis. But yes, we should probably do the footprint analysis. I don't have that answer on the top of my head.
Okay. Look, there are some more questions, but I'll let you guys carry on. Thank you for fielding those right now. That's very helpful and interesting.
Yeah, absolutely. Thank you. We appreciate the questions, and I'll turn it over to Raul to kind of continue on.
Yes, I think Nikki, you asked the question on would the tool highlight if the lat-long provide differs from locations noted within the supporting documents provided? So the answer is yes, and I think these are the things which the agent can do really well. We have had cases when in the last 1 month wherein the not the address but the location and the state where or the county where the site was different in the geotechnical report. It was different in the submission document, and what ended up in the DRA was different, right? So I think it's not just about catching these, but it's also about catching hundreds of these simple things, which makes it extremely, which makes it extremely potent here. And I think John also answered the question of, have the results been compared with human risk analysis? And the question is, how hallucination reasoning are handled by agents? Cool. So I think John answered these. But I think but if we look at it more simpler, it's not actually very complicated to calculate the accuracy. I mean, if this agent is mimicking what a human is doing, the way to assess it is also going to look very similar to that. So what we usually do is, when we are assessing the effectiveness or the accuracy, it is obviously every company has some sort of a template how they create DRAs, right? So we adapt to that, and we take, let's say, X number of historical DRAs which were created. So let's say you, in the last 1 year, you have created 10 DRAs, and those 10 DRAs would have been created by inputting submission documents on their own, right? So what we do is we again take the submission documents of those 10 DRAs historical, and we create the second version of DRA. Now we have two versions of DRA to compare against. And we probe these both documents with a set of questions, like how a professor would rate, which of these, answered the question very well. And these questions could be, depending on the length and breadth of it, it could be between 10 to 50 to 100 questions. And then we rate these answers based on completeness, based on, verbatim correctness, and the context, and we come up with a score, right? And we come up with a score, and that score is something which is used to continuously evolve, as to how this is behaving submission after submission, which also answers the question is Natalja asked, is the tool learning the more similar projects are reviewed and considered possible claims for same technologies or clients? I think, yeah, I think there are, the way the tool potentially will learn is obviously how I explained in terms of how do we calculate the accuracy. So if the accuracy over a consistent amount of time starts to drop, so this needs to be acknowledged, and certain reinforcement needs to be done to bring it back up again. So that is just a leash through which we understand how it is behaving, and the very same leash can be used to make it learn other similar things. But also in the context of claims, historical claim context is extremely useful. From the, if ingested, if integrated, it can sort of pick up those patterns. There is also, I think, a question in the Q&A section. I'll go there.
Rahul, do you want to continue the presentation and we'll come back to questions later, or
Absolutely.
or field all the questions? It's up to you, but I don't want us to miss some key material that you prepared.
Fantastic. So yeah, so far, essentially, I think Q&A and our webinar up until now, we've talked a lot about problem and the shape of the solution, and also the solution itself, So, but all of it said and done, what decides success now is adoption. Trust, defensibility, and the fit with how risk teams potentially are going to use it. So at this point, let me tell you a very interesting story. And the story involves is dated back in 2016, and it involves Jeffrey Hinton. He's one of the fathers of AI. He's godfather of AI, and he's also Canadian. But he predicted something. He predicted that AI would replace radiologists within 5 years. And this was it was at least in the circuit of AI and adoption. It was in use, and a lot of people took that seriously. Medical schools actually got worried, and students at that time who were completing the medical degrees, they reconsidered the field. And fast forward to today in 2026, what we are seeing is AI touches almost every scan. But the outcome wasn't, fewer radiologists. Mayo Clinic employs more radiologists than it did back then, even after accounting for demand. So why? Why did that happen? Why did Jeffrey Hinton got it wrong? Because AI took over the repetitive first pass work. So radiologists who are experts in their field, and you have really got that skill with experience, spent more time on the hard part. And the hard part in the context of radiologist is judgment, collaboration with patients or clinics. So what ended up happening was capacity went up, demand expanded, and the expert role got more important. And the reason I'm talking about radiologists in today's webinar is because there is a parallel here. In the context of what we are doing, in construction insurance, or even the wider risk engineering for these complex sites, which are getting complex every passing day, we're not trying to replace engineering judgment here. We're trying to take the time sink in data hunting, cross-checking, formatting, and give that time back to risk engineers. And the question which was asked was, can it find out where the platform is wrong? Those small things. Two larger things so that it can find the right map. So what really decides success now is adoption, whether this fits the risk teams. And at the end, let me leave you with three things I would want every risk and underwriting team to sort of take away from today's webinar. That number one is, this isn't a hypothetical problem. The risk engineering workforce is shrinking by about 40% while submission volumes are growing. At the same time, we are seeing larger and more complex sites getting built, tighter build timelines, higher DSU exposure, and that combination creates real pressure. And the key point here is simple. Insurers need to scale the capacity without lowering the quality of judgment, and hiring alone won't get us there. Point number two is, we consistently hear that 70 to 80% of an engineer's time goes into data hunting, also reflected in today's survey, in which around 80 people responded. And it is not judgment. And that's not where expertise create value. So AI agents do not replace judgment. They remove the friction around it. They handle repetitive, time-consuming work, so you can focus more on what you do best. Understanding the context, weighing in trade-offs, making complex decisions, and the same pattern as I mentioned about radiology. AI expanded the capacity, demand grew to meet it, and professionals became more and more valuable. And the third point is, most AI tools today, if not in the agentic space, are point solutions. They do one task well, and when they don't carry the context across the full workflow. So what's been missing is a system that can hold evidence, reasoning, and decisions together from submission to the final assessment. And that's why specialized AI agents come in. An AI agent could be in any field, but to be able to hold the evidence and reasoning together, something specialized for this workflow needs to be built. And they're supposed to be context-aware, adaptive, and able to reason across documents, maps, and other kinds of reports. So in practice, that means teams can move from submission to defensible desktop assessment in hours instead of weeks without losing traceability or the control. So the main idea I would leave you, or I'll conclude the webinar before we go to the extended Q&A, is that obviously engineering judgment is becoming more and more valuable, not less, but only if we give it the right support ecosystem and the space. And AI agents aren't about replacing expertise, they're about carrying the context. So thank you for taking out the time in attending today's webinar. Obviously, we can go deeper in any part of what we discussed and showed, or even go beyond if you have any question. But we'll be opening for questions. Thank you.
Thanks, Rahul and Jean. I think you can see from the level of questions that you've had how engaged the audience has been. So thank you. There are some other questions that I think would be worth spending a bit more time on if we can. And I don't know if you, I know you're following the questions yourself. So you can see in the Q&A tab, the first one there from Peter, it's quite an interesting question in that, do we not need to spend time absorbed in and finding data in order to learn, generate the experience and learn learn our expertise in order to be able to make the judgment calls? So how does adopting this kind of methodology, does it not risk de-skilling the very engineers that you want to make the judgment calls at the end?
Yeah, that's an excellent question, and
Yeah.
I think I meant to touch on it a little bit. So, at least in my opinion, right, like the baseline for a new grad entering into the risk engineering world, these are smart, intelligent people. A lot of the time-consuming work is about data gathering and reviewing the documentation. In our opinion, that actually takes away from a lot of the learning, a lot of the time that could spent having kind of mentorship hours with the more senior risk engineers, and kind of checking and validating the assumptions, especially when we're looking at potential loss scenarios and things like that. So we might be a little bit biased, but at least my view is it actually will enhance learning opportunities because you're not scrambling to do kind of busy work as a more junior employee. Because I know when I started, though I wasn't in the risk engineering world per se, I spent a lot of time doing busy work that wasn't always the most valuable for my learning in enhancing my own judgment.
Yeah, and I guess it's like any tool we're given, you need to, cross-check a question against your knowledge and understanding rather than just blindly follow and accept. Interesting question here about confidentiality of information. Data shared to us. So the underwriting information that we provided is confidential, not meant to be shared with any other third party, which may compromise. So this could be compromised while uploading onto the platform. So how do you deal with the confidentiality of underwriting information?
Yeah, Raul can kind of touch on the certification. I will say for like the demo, that was publicly available information. So we are very cautious in terms of, we don't share any previous submissions or anything like that, whether it's for marketing material or anything. But Raul can get into kind of the compliance piece.
Yes. So first of all, at the organizational level, like, getting the SOC 2 compliance and HIPAA and all different kinds of compliance in order, that is required. But I think that is required for handling any, insurance related data or documents. Now, in terms of confidentiality, I think there are different layers of masking which can be done, which is very specific to the company which we are working and the team which we are working with. So with different degree of masking of information, it is something that really helps to put the ball to move ahead, and that has been that is something which we have been doing for this.
But is it a closed system as such? So that anything that goes into your system isn't interacting with the wider the full internet?
Absolutely no. It is not only so the very nature of this system is that it is not supposed to either interact with the internet outside in terms of pushing data, but not even receiving data, because that is what increases the hallucination. So the system is not mandated. It's not allowed to even go and search the internet on its own unless it is fed in the instruction set, the boundaries and the guardrails. So it is two-way.
Okay.
It does not take data from inside to outside, expose it to outside, or from even get there could be some random blog which talks at length about conspiracy theories about a site. You can't be bringing those information in the DRA's assessment, right? So I think so it is two ways, and there is multiple layers of also masking of the location even when we interact with the authorized sources.
Okay. So sorry, you may have answered this already. Apologies if I missed it. But the question is the tool learning the more similar projects are reviewed and consider possible claims for the same technologies or clients? So is it a live learning model, or does it require maintenance to update knowledge?
It's more from the learning perspective. It is learning, but it's not necessarily immediate. So we take the results in and we do a proper validation internally, look at everything very closely, a lot of manual work, and then update the models as needed. and that ensures, there's not like a constant evolution where the accuracy rate and things like that are changing without us being aware. So we very much continually improve it, but are very cautious of where we make those improvements, how we make those improvements. And I also see there's a really quick question there around the size of max data that can be uploaded. We work with owners as well that have a ton of LiDAR data. I think we can do several hundred gigabytes. We had an owner try to do 2 terabyte, a 2 terabyte upload. That didn't work, but I don't think in the insurance workflow, there's 2 terabytes worth of data that'll ever be encountered. So yeah, there's no reasonable limitations on the max data upload.
Okay. Natalia has asked about costs of licenses and the like. That's not a subject for today, but Natalia, I'm sure you can make contact with Rahul and Jean separately. Next question is about, so which large language model are you using for the information extraction from reports?
So I think on that front, I think there are 3 different kinds of models: Google, Anthropic, and OpenAI. We are primarily right now using the Google's model, but I think the pace at which this industry is moving, every passing quarter there is something new. So essentially, depending on how the performance is, we can sort of migrate on a use one model versus another. But so far we have been using Google models, at least in the product.
And the specific models, like I mentioned, we're a multi-agent environment, so we pick the best tool for the job depending on what that specific job is.
Yeah, apologies. I saw that you answered that question. I hadn't scrolled down far enough, so apologies for repetition there. Just checking, have you answered the question from my colleague Ollie? No, you haven't. So Ollie is saying the checking of the AI output is a new task, and I guess he's saying that's inevitably then going to be added to the risk engineer's workflow. So will that checking process be integrated into your product?
Yeah. So, Raul, go ahead.
No, go on.
So we have a few thoughts on that. So for one, we're currently working on making sure that the results are transparent and conducting an automated validation for some preset questions that can be reviewed. So you run an assessment, you can kind of see a confidence score of sorts, and then. But the other piece is, yes, this does reflect kind of a change in process for the risk engineers, and we realize that. Part of how we, at least during the pilot process, we kind of conduct the validation alongside our partners, and then the intent there is to kind of understand like what is the probability that this risk assessment is accurate and similar, and if you're at say a 90% accuracy or completion rate, then it's a matter of checking for that 10%, and users over time will kind of understand like what are the more what information is more exposed to potential hallucinations, misinformation, or things like that. But again, because it's a closed system, it's really more about the making sure that all the right information is being surfaced, and that's why it's not just the reporting piece. There's the ability to kind of quickly check things and see the source documentation in the chat itself. So we have some work to do in terms of features to help streamline the validation, but we do believe that given how much time is spent just extracting information from the submission documents and all those external data sources, that it would still be quite a large net positive in terms of time saved.
Yeah.
Good. Thank you. Interesting question from Clara there about cybersecurity. What's your measures to combat potential for a cyber attack?
Yeah, absolutely. I think we have been in business for last 4 years now, and over the period of time, we have, like us or any other company who works with the likes of, let's say, Amazon or Zurich Insurance or any other company which has huge amount of sensitive information. We need to go through the process of streamlining our internal processes in terms of governance and specifically on the cybersecurity. So that is what we have been building over the last couple of years. Now, to keep them, what we do is we have regular check-ins, regular reviews and audits on our usage of the cloud services, our usage of our in-house data centers, which is hosted in Toronto. So I think those are the measures which we take in place to ensure that we do not get hacked. But yes, I think it's very important topic, especially dealing with these kind of very sensitive information.
Yeah. Okay. Question here about the language of the material. Can the platform deal with multiple languages, and the question asked, can it be then produce the output in a single language? But I guess an extension of that question is, can the output be produced in any language?
Yes. So the essentially with the kind of models which are there, I think doing these things is extremely, it is feasible. However, we have not done these kind of in the production environment right now. The product in current stage, we do not have the feature to ingest into multiple languages, but we do have tested between French and English in the past, and in terms of parsing complex reports, and that has worked. So if there is a requirement to pilot it on these kind of documents, it is certainly that we can build it.
And that's on our near-term roadmaps, Raul. And in terms of the translation, this isn't a challenge specific to us. As with any translation service, you may have some semantic changes and things like that. So there can be a slight difference in terms of the native language versus the translated version. But overall, it's not an issue. And we do have English and French supported in the platform because we are Canadian. So a lot of our clients are French.
Okay. Another good question here about, so a lot of the underwriting, particularly the technical underwriting information we get given is often in drawing form or diagrammatic form. So how adept is the platform at dealing with that information and collating it, integrating it into the response?
Where we're at right now for technical drawings, and there's a lot of construction technology that's kind of focused in this space, is we can extract information from the technical drawing pretty readily. The interpretation of that technical drawing requires further R&D. And that's kind of a limitation of where the models are right now. So we won't claim to say, we can fully understand the site drawing and all of the associated construction activities and risks in that drawing. That's not what we're saying. We're saying you can extract information, high level information from that drawing. But we didn't get into it today, but we have what's called a knowledge graph, kind of powering the context in the background. And so what that can do is look at a site drawing and understand, for instance, the geospatial relationships. So this isn't necessarily applied to insurance, but from a mining perspective. So we do a lot of work with like tailings facilities, and we can understand that like a monitoring location is downstream of a tailings facility, so that if there's like pH changes detected in that, that CSV output of the monitoring data, that represents a potential leak or something like that. So we kind of apply the same to understanding the site.
Just to add to Oliver, your question on the last part of your question on borehole logs, that combine text output and borehole logs. So these kind of tables and everything, the geotechnical agent is able to parse through it. Is able to infer that there are 6 boreholes, and these were dug in these points in time, and the water was hit on, let's say, 5 feet versus 10 feet versus 4 feet in these borehole logs. So it is able to do those things. So I think, and in fact, even actually capturing the diagram, it is feasible. But obviously, there is more, like the more sophisticated, drilling, the more sophisticated, inference you want to make, the harder it gets. So I'm very curious. I think we'll reach out to you separately, and I think we should see. What is the context of these extraction information you're looking at? Maybe a lot of it we already have, but it's always good to understand what is the limitation so that we can work on it.
Okay. Thank you. Look, I'm sorry, there may have been other questions in the text, and so audience members, if I've missed your questions, I'm sorry, but we are running short of time, and I'm selfishly going to ask one of my own. In the survey you asked us at the beginning, I thought there was a really interesting question about people's kind of readiness and willingness to engage with AI tools. And I just wonder whether you've got the results that you might be able to share with us, because it's sort of, the question was around, kind of how aware are we of AI tools, how cautious are we about using them, and then how open are we to adopting them. There we go. Yeah.
Yeah,
perhaps you could just talk us through what we've said to you there, please.
Yeah, no, I think this is really interesting. So I'm glad to see that the confidence is pretty high overall for the group here. I think if we were to ask this, a year or two ago, we would have seen a completely different response rate there. But there's still some reservations, and I think for this line of work that makes complete sense. I still have reservations of using it in my own work. But the curiosity piece, I think, is the coolest. So given the lack of risk engineers compared to demand, I think that's really good that a lot of the folks here are strongly agreeing there. Obviously, a little bit biased because everyone here did sign up for an AI related webinar.
True.
So there's, yeah. And we can go through some of the other responses really quick. So in terms of desktop risk assessments, fairly normal distribution here, but most people are spending around 5 to 10 hours for their DRA. And if we look at the first question, or the second question here, most of that time is being spent reviewing submission documents and looking at external data. And it's good to see that the communication with the brokers isn't too much of a bottleneck. So everyone's friendly with their brokers. And then the first question that Raul mentioned, I also think is kind of cool to see that kind of what one word strikes or comes out. So efficiency, obviously risk, limited. So probably dealing with a lot of limited information. Again, that's very different from the owner perspective. And then, yeah, and we can share these responses. So
okay.
What risk factors do you struggle with the most? So quality of data, absolutely. Phase site conditions, that is often very challenging, especially comparing the milestones to the different policy timelines. What else? Yeah, so Patrick, any of these strike out to you?
Well, interesting. If you go back to the word cloud, I thought that was interesting, and I would do, wouldn't I? Because I also wrote down information, and that was because I was thinking about, we often get so much information, we're not necessarily given the information we want. We have to go looking for other information. We have to filter and sift through to find what we want, and that really, that's a great place to finish, I think, because that's exactly, of course, what your platform is offering, is to cut through all of that, find out what we do know, to identify what we don't know, and free the human being up to add the value in that process. So I'm just going to use that as an opportunity to wrap up today, to thank Rahul and Jean for a fascinating presentation. They're both very willing to be contacted afterwards for anyone who wants to interact further. But a really fascinating presentation and a real window into the very near future, let's be honest. Thank you both.
Thank you, everyone.
Out the webinar, just place your questions in the Q&A section. And now I'm going to hand over to you. Thank you, to Patrick. Thank you, Patrick.
Thanks, Stephanie. Thanks. So today we're going to take a step into the future, or actually what is increasingly becoming the present. So we're all learning so much more about the potential for AI to help us in so many aspects of our lives. And we're increasingly seeing tools and techniques being introduced into the insurance industry. Some of you may already use things like Copilot to produce meeting minutes, draft emails, summarize reports, and the like. But today we're going to get a window into the next generation of tools, if you like. And these are tools that will help process large quantities of underwriting information and then provide us useful insights that are aligned with our risk appetite